Yes, self-induction, phenomena of self. Once we cover this, then we will have a mutual. Next lecture will take into account the mutual induction. Self means something related to oneself, the wire itself. Mutual means two wires, two coils. So, if there is a wire, it carries current I. If there is no current, there is no magnetic flux. When current I flows through this, there is a magnetic flux in the same. So that means when there is no current, there is no flux. When you change the current from 0 to I, there is a flux. There is from 0 to phi. Whenever there is a rate of a change of flux, there is an EMF induced. So that means there will be some voltage induced in the wire itself which will try to oppose this increase of flux. This phenomena of inducing EMF in the wire itself is known as phenomena of self-induction. So repeat. When current in a wire or in a coil increases, magnetic flux phi also increases. As per Faraday's law of EMI, an EMF is induced such that it tries to oppose the cause. In this case, cause is increase in current. So EMF is induced so that it does not allow easy increase of current. Same is true for decrease in current. If you try to decrease the current, the wire doesn't allow you to decrease, because as per Lenz's law, EMF will be induced such that it tries to oppose the cause. Self-induction is a property of a coil or a wire by virtue of which the coil opposes any change in the strength of current flowing through this. If you try to increase the current, EMF is induced to oppose that. If you try to decrease current, EMF is induced so that it will oppose whatever change you bring. For this reason, self-induction is also called the inertia of elasticity. What is inertia plus 1? If object is at rest, it will continue or tendency to remain at rest. If you change that state of rest, it will oppose. If it is in motion, it will try to be in motion. If you change, it will oppose. So if you increase current, there is opposition. If you decrease current, there is opposition. EMF is induced such that it tries to oppose the cause. This phenomena, this property is property of self-induction, and the phenomena is known as phenomena of self-induction. So in brief, property of a wire or a coil to oppose any change in current, or you can say change in flux. Time with you is 3 minutes to write phenomena of self-induction. Phenomena of self-induction. This is phenomena of self-induction. When you say opposition in a wire, so opposition is something, a property. In order to account for that property, you write resistance. resistance. Resistance of a wire takes into account the opposition. So you can measure resistance, you can write formula. Here also, self-inductance will give you the numerical value of the same. Magnetic flux phi m is proportional to I. That's correct? If the current flowing is 0, what is the magnetic flux? 0. If the current increases, magnetic flux also increases. Is equal to L into I. What is L? Constant of proportionality. It will do what? It will give you some idea about flux flowing per unit current. I will explain how. If there is a wire 1 ampere small flux, that means what? Self-inductance is less. Another wire 1 ampere current, too much of flux, that is, if you make a solenoid or a coil, then the magnetic flux will come out to be more or less in comparison to this case. Magnetic flux will come out to be more. That means value of L will be more. For the same current, if 1 ampere current is flowing here, flux is less. Here, if 1 ampere current is flowing, flux is more. So, L represents a coefficient of a self-inductance, 1. What are the SI units? Yes, SI unit is Henry. Sorry. Dimensional formula. Dimensions of L are same as that of magnetic flux divided by current. Magnetic flux is what? Dimensions of B into area by I. I will write A as area because A sometimes you represent as ampere. Yes, some relationship between B and F. Yes, F is equal to BIL or F is equal to BIL, B is equal to F by IL into area divided by current. Yes, force M1 L1 T minus 2, area length square, I ampere, L length. The result is M1, yes, check करके बोलो, L2 T minus 2, A minus 2. So, dimensional formula for objective question in competition, dimensional formula for coefficient of self-inductance is M1 L2 T minus 2 A minus 2. Time with you is 4 minutes to write. We can add on one more step here. So, whenever there is a flux change, EMF will be induced. EMF induced E is equal to minus ddt of a phi. Negative sign shows as per Lenz's law, EMF is induced such that it tries to oppose the cause. If a phi means phi magnetic flux is equal to minus ddt of phi m is equal to what? Li. is equal to minus L di by dt. In any of the numerical, if you come across, you have to find out EMF, then it is L, coefficient of self-inductance, di by dt, rate of change of current with the time. 1 minute to complete. Based on this principle, we try one numerical, numerical number 10. Page number is 4 by 40. Numerical is magnetic flux of 5 microweber is linked with the coil when a current of 1 milliampere flows through it. What is the self-inductance of the coil? What is given? What is required? Given is what? Magnetic flux. How much? 5 micro or milli? 5 micro. Yes. 5 into 10 raised to power minus 6 Weber. What else? When a current of 1 milliampere, 1 into 10 raised to power minus 3 ampere flows. What you need? Find L. Yes, concept to be used is what? Phi m is proportional to I, phi m is equal to Li, and L is equal to what? Flux per unit current. Flux is how much? 5 into 10 raised to power minus 6. Current is how much? 1 into 10 raised to power minus 3. What you get is 5 into 10 raised to power minus 3 SI units. SI unit is Henry. So 5 into 10 to the power minus 3 Henry or 5 milli Henry. Question number 7. You have to prove self-inductance of solenoid. You have to derive an expression and prove self-inductance of a solenoid is equal to number of turns square by reluctance. Arrangement is, for an electromagnet generally it is a iron piece or a good quality ferromagnetic material like steel. You have a winding on the same. Number of turns are there. Say 1, 2, 3, 4, 5, 6. In this case, number of turns 6. There is some current flowing I. Because of this current, there is a flux or flux linkages. We have to find out self-inductance L for the same case. 1 minute to try. Go through the article 1 minute. उसके बाद notes बंद कर देने हैं. 1 minute. Go through the content. Notes बंद कर दो. As per definition, L is equal to, if it is a single wire, flux per unit current. But if there are number of turns, then total flux linkages, to be written as xi, not phi. Phi is a flux, xi is the total flux. 1, 2, 3, 4, 5, 6. 6 times phi m is xi. That is why total flux linkages per unit current, it is equal to N into phi m by I. N by I, as it is, magnetic flux is equal to what? Magnetic flux density B into area A is equal to N by Ni. B is equal to what? Nu times H. It is nu naught, nu R, H, A. It is equal to, H is equal to what? If L is the length, H represents MMF, Ni, total MMF divided by total length, MMF per unit length. So it is what? N by I nu naught nu R. H is equal to what? Ni by L A. I cancelled. What you get is L is equal to N into N, N square, into nu naught nu R into A by L is equal to N square L nu naught nu R A. Yes. Equivalent to electrical resistance. Electrical resistance is equal to length of the wire divided by conductivity and area for a wire. For a magnetic material, reluctance, opposition to flow of flux, reluctance is equal to length. Equivalent of conductivity is what? Permeability, nu. Nu naught into nu R is permeability, A. So it is equal to what? N square by reluctance. So self-inductance of a solenoid is equal to N square by reluctance. Time with you is 4 minutes. 4 minutes to write. If you have written it, you can refer to numerical number 13, 1, 3. Numerical is if the self-induction of an air core solenoid increases from 0.04 millihenry to 16 millihenry on introducing an iron core into it, what is the relative magnetic permeability of the core? What is given, what is required? Draw a diagram to represent. Initially it was what? Yes. Initially it is air core. Correct? And the material, magnetic material is lying say outside. A rod is lying outside. It has nothing to do with this. So there is some self-inductance L. First part experiment. In the second stage, what you have done is you have pushed it. You push it inside. If you push it inside, the new diagram, the new value is say L dash. And the new diagram is where is the iron material rod now? It is inside. As per this formula, L is equal to this nu R can be shifted upwards. That means what? L is proportional to solution. L is proportional to nu. Correct? Higher is permeability, higher is the value of L. You can see this nu, here it is in denominator. If you shift it upwards, it is in numerator. So that means L dash by L is equal to nu dash. In this case, second case, nu is equal to what? Nu naught into nu R of iron. First case, nu naught into nu R of air. The first case is air. Air is how much? 1. So L dash, this nu naught cancel. What you get is L dash by L is equal to what? Nu R. What is value of L dash? Yes? 16 millihenry. L dash. What is value of L? 0.04 millihenry. Nu R comes out to be what? Nu R comes out to be, yes, nu R by 1 is equal to L dash by L. L dash is how much? 16 millihenry. L is 0.04. What you get is 400. Nu R of this material is 400. Notes, question number 8. Mutual induction, phenomena of mutual induction. When you say phenomena of mutual induction, you will get a coefficient of mutual inductance. A coil, coil 1 or solenoid 1 or primary turn of a transformer, it carries some current I in primary. You can write it as I1 also. If you call one coil winding as primary, the other is secondary. Another winding nearby, close, one winding, another winding, and they are close enough. So when the current flows in the primary, there is a flux in the primary. Because secondary is nearby, it is, if you call this as 100%, call this say 90%, 90% of the flux is linking with the secondary also. If you change this current, there will be flux changes in the primary. So there will be EMF in the primary. That phenomena is phenomena of self-induction. But nearby coil, there is a flux linking with the nearby coil also. When you change this current, this flux will also change. When this flux changes, EMF is induced in the secondary also. This phenomena is known as mutual induction, phenomena of mutual induction. So, flux linking with secondary depends on current in primary, and again the constant of proportionality is M. M is equal to what? Phi S by IP. What are the units? Same. SI units are same. Henry. Dimensions same as self-inductance. What was the answer? M1, L2. Correct? Time with you is 3 minutes. Board 2 marks question. 2 marks question. What is the coefficient of mutual inductance? It is a ratio of flux in secondary to current in primary. Units, Henry, dimensional formula same. M1, L2, T minus 2, A minus 2. Question number 9. We have to prove coefficient of mutual inductance of two coils is N1, N2 by reluctance. This is what we have to prove. Notes band. How many coils are required? 2 coils are required. So, a quality magnetic material, say iron, and you have winding 1 with a certain number of turns N1. It carries some current IP or I1. Then you have another winding, number of turns is N2. As per definition, mutual inductance is equal to total flux linkages with the secondary. There is a flux linking phi. Phi is the flux linking. Total flux linkages with the secondary is N2 into phi for per unit current in primary, that is IP. So previous question, it was the flux linkages divided by current because there was only one coil. For self means one person, mutual means two. So in this arrangement, it is N2 by IP. Phi is equal to what? B into A. B is equal to what? Nu not nu R, that is, let me write nu H. H is equal to what? H is equal to mmf per unit length. Length here means the total length of the wire, of the rod into area A. This H here, number of turns N1. IP is cancel. What you get is M is equal to N1 N2 nu A by L, can be written as N1 N2 over L nu A. Yes. Length by permeability into A is what? Reluctance. N1 N2 by reluctance. So M is equal to N1 into N2 by reluctance. M is coefficient of mutual inductance, N1 is number of turns in coil 1, N2 is number of turns in coil 2, reluctance of the circuit on which the two coils are placed. Time with you is 4 minutes to write. 4 minutes. Refer to numerical number 19. Question is, two solenoids A and B spaced close to each other and sharing the same cylindrical axis have 400 and 700 turns respectively. How many turns of A? 400. B 700. A current of 3.5 ampere in coil A produces an average flux of 300 microtesla meter square through each turn of A and a flux of 90 microtesla through each turn of B. No doubt they have given it to be same cylindrical axis, but it helps me. That is why I will draw not same axis. One coil. Number of turns in one. Yes. How many? A. Number of turns in A, sorry. Yes. 400. Number of turns in B. Number of turns in B is 700. There is a flux linking. Is it same in the two? No. Flux linking in primary. How much? 300 microtesla into meter square? Yes, meter square. So it is micro. That means 300 into 10 raised to the power minus 6 SI units. What about the flux linking with the secondary? 90, less. It is 90 into 10 raised to the power minus 6. Why it is less? Because of this leakage. Flux leaving this winding is 300 but reaches only 90. If you move it further away, the flux will further keep on decreasing 90, 80, 70. If you take it to infinity, flux linking with the secondary will become 0. Objective questions. What is required is, so complete question, a current of 3.5 ampere in coil A produce an average flux of 300 microtesla meter square through each turn of A and a flux of 90 microtesla meter square through each turn of B. Calculate A part. Yes, find what? Mutual inductance. Current in primary is how much? 3.5. Definition: total flux linkages with secondary, that is NB into phi B. Total flux linkages with second, that is B. Per unit current in primary, IA. Put values for NB phi M. NB is how much? 700. Phi B is how much? 90 into 10 to the power minus 6. IA is 3.5. Solve and find M. In SI units, Henry. In SI units. Yes. 1.8 in 10 to the power minus Henry. So M, which was not known, now is known. 1.8 into 10 to the power minus 2 Henry. How many of you are getting this answer? B part, try B part. Self-inductance of A. Self-inductance of A. Refer to the basic. That is the definition of self-inductance. Definition is, yes, total flux linkages with the itself, that is A, divided by current flowing in A. Solve it. NA is how much? 400. Phi A is how much? 300 into 10 raised to the power minus 6. IA, current in the primary, 3.5. What you get is? Yes. 3 into 10 raised to the power Henry? Same answer? C part. What EMF is induced in B when the current in A increases at the rate of 0.5 ampere per second? What EMF is induced in B means the secondary is equal to rate of change of flux in secondary. Rate of change of flux as per the definition in secondary is equal to what? It is M times IP primary is equal to M into ddt of IP. EB is equal to M into ddt of IA if rate of change of current is given. Given? So put a value for the same. M is equal to what? 1.8 into 10 raised to power minus 2. dA by dt is how much? dA by dt is 0.5 ampere per second. 0.5 comes out to be what? Yes? 9 into 10 raised to power what? EMF.